This is Mr. White doing the video. As you can see, this is for our Algebra 2, Unit 4, Lesson number 2, Skill Practice. Let's get into this, looking at the zeros of our polynomial functions and then graphing our polynomials. On this first one, we are in standard form, so this needs to be put in the factored form so we can find out what the zeros are, but at least we already know what the end behavior is. We have a negative leading coefficient with an even degree, so that's our penguin. As x goes to negative infinity and as x goes to positive infinity, our function goes to negative infinity on both of those, as we can see right here. So now let's look at these zeros. All right, so now what I want to do, I want to keep everything mathematically accurate. So that means finding our zeros, we want to set this equal to 0. So now that we're solving this equation, I want to multiply everything through by a -1. So I'm just going to do all my working in this empty space up here. All right, and that's going to give us x to the 4th plus 3x squared. No, x to the 4th minus 3x squared. That's right, I multiplied through by -1. And minus 3x cubed minus 10x squared equals 0. Now I want to factor out an x squared. So I'm going to have x squared minus 3x minus 10. Still set equal to 0. Now I can factor this interior portion, so that gives me x squared, and that factors to x minus 5, x plus 2 equals 0. So now that I have my function in factored form, and let's go ahead. Really don't feel like going back and forth. I want to make sure I follow my directions properly. So this is the format we're supposed to have our answer in. And I'll go ahead and say it touches and turns at 0. Well, do it this way. Cross. We know it crosses the x-axis at x equals -2 and 5. And I'm going to put T and T for touch and turn at x equals 0. All right, we don't have a binomial with this, we just have this x squared, so that means it's x equals 0, and again, it touch and turn at 0. All right, we can see for this next one, it's already written in factored form, and since we're looking at our zeros, this stuff doesn't matter over here. Well, it matters for our end behavior, so let's count our factors. We have 1, 2, 3, and 4. So this x squared minus 16, again, we have the exponent of 2, and that factors out to x plus 4, x minus 4, and that x minus 1 squared is just a double root, right? A double root at x equals 1, so we have touch and turn at x equals 1, and it crosses at x equals positive and -4. So just like the first one, we have a negative leading coefficient with an even degree, and it's 4 again. So we have our penguin, and again, the function goes to negative infinity as x goes to negative infinity and positive infinity. All right, now this one right here. Okay, again, let's set it equal to 0. And I'll do it right beneath that one. We have 4 terms, so that gives us a hint. Hey, we're probably going to be able to factor by grouping. If we factor out an x squared, that gives x plus 1. And then if we factor out over here, factor out a -9, that also gives us x plus 1. Again, I like to be as neat as I can writing on this tablet. Okay, and now again, still set equal to 0. slip that in. So we have x squared minus 9 and x plus 1. Still set equal to 0. We still have a degree of 3. 1, 2, 3. We recognize our difference of 2 squared, so that's x plus 3, x minus 3, x plus 1, all equal to 0. And we already have our end behavior. We have a negative leading coefficient with an odd degree. So that's our discode down to the left, up to the right. So down to the left means as x goes to negative infinity, our function goes to negative infinity. As x goes to infinity, our function goes to infinity. And zeros, we're crossing. We have a degree of 3, so we have 3 zeros. We're crossing at x equals negative 3, negative 1, and at x equals 1. All right, let's look at this next one here. Why did I say number 10? Oh, well, anyway, this is number 4. And I don't have room, so let's just go ahead, erase all of this here. And now we set this equal to 0. So we have negative x cubed minus 3x squared plus 4x equaling 0. Well, we'll do our end behavior later. Multiply through by negative 1, so we have x cubed plus 3x squared minus 4x equals 0. Now we can factor out an x. Factor out an x, that gives us x squared plus 3x minus 4. Plus sign doesn't look much like a plus sign. All right, and we can factor this interior portion, that x, we have x plus 4, x minus 1 equal to 0. So our zeros, we have, each one of them has a multiplicity of 1. So we're going to cross. At x equals negative 4, 0, and at 1. Now for these last two down here, all right, these last two down here. So we have our x plus 1. This has a multiplicity of 1. This x squared minus 9. Again, we recognize our difference of 2 squares, x plus 3, x minus 3. Each one of those have a multiplicity of 1. And this 2x minus 1, that is the same thing as saying x minus 1/2 raised to the third power. All right, so we have 1, 2, 3, 4, 5, 6. Our degree is 6, and we have a positive leading coefficient, so that's our touchdown. Our function goes to infinity as x goes to negative infinity and positive infinity. And we already have our zeros are crossing, since each one of them has an odd multiplicity. We're crossing at negative 3, negative 1, positive 3, and 1/2. And I should have put that 1/2 before the 3, because I just like to put them in numerical order. And for our last one, we recognize another difference of 2 squares, so that x minus 4 is x plus 2, x minus 2. Our degree, 1, 2, and 3. So x plus 2, x minus 2, and x minus 4 each has a multiplicity of 1. So we're crossing at -2, 2, and 4. And our odd degree with a positive leading coefficient means that is what our end behavior looks like, and that is the description of our end behavior. Okay, that's going to do it for that first part there. Now we want to get the graphs or write the equations of these functions based on the graph. And we're going to have to make some assumptions here. We're already saying that each tick mark represents one unit. We got to assume there are no dilation factors. And my numbering got mixed up when I did my copy and paste. So this is actually 7, 8, and 9. All right. So this first one right here, number 7, we've got f of x equals, we have where as x goes to negative infinity, f of x goes to negative infinity. As x goes to infinity, positive, f of x goes to positive infinity. So we're down to the left, up to the right. That tells us we have a positive leading coefficient with an odd degree. We only have 2 turning points. And remember, our degree is, well, the maximum number of turning points is our degree minus 1. So since we have 2 turning points, we can go ahead and assume our degree is 3. So we have, that's at -2, so f of x is going to equal x plus 2. Also, it crosses at positive 1, so that's x minus 1. And it crosses at positive 4, so x minus 4. And it says for 7 and 8, we want to write these also in standard form. So standard form, let's go ahead. We need to multiply everything through to get it in standard form. So multiplying these 2 binomials, we have x squared minus x plus 2x. So that's plus x minus 2. And then we want to multiply that times x minus 4. Start with my 4's here. So that's going to be multiplying this through x squared times x, that's x cubed, x squared times -4 minus 4x squared. Now, x times x is x squared, x times -4 is -4x, and then -2 times -x is -2x, and -2 times -4 is a positive 8. So combining all of our like terms, notice how I get my columns there. We have x cubed, -4x squared plus x squared is plus 3x squared. -4x minus 2x is -6x, and then our plus 8. All right, looking at this number 8, we have f of x equals, we have -1, -2, so x plus 2. And actually, no, let me back that up. As x goes to negative infinity, f of x goes to infinity. As x goes to infinity, f of x goes to negative infinity. So we have a negative leading coefficient with an odd degree. So we have, what was it, x plus 2. And then it touches and turns at 1, positive 1. So x minus 1 squared. Now, if we want to multiply these two, we can't just multiply x plus 2 times x minus 1 squared. We have to multiply out this x minus 1 squared first. And that multiplies to, let me go ahead and show it. I'm not going to skip anything here. So that is x minus 1 times x minus 1. And that equals x squared minus 2x plus 1. And we want to multiply that times x plus 2. So again, this is going to give us x cubed plus 2x squared, x cubed plus 2x squared. Now we have negative 2x squared minus 4x, and then x plus 2. And now putting all that together, we've got a negative. All right, don't forget about our negative out front. Negative, and that is x cubed, 2x squared minus 2x squared. Those sum to 0. So x cubed, negative 4x plus x, minus 3x plus 2, which equals negative x cubed plus 3x minus 2. And number 9 over here. All right, let's look at our end behavior. As x goes to negative infinity and as x goes to infinity, our function goes to negative infinity on both of those. So we've got a negative leading coefficient with an even degree. And we're at negative 1, negative 2, negative 3. So that is x plus 3 squared, and 1, 2, x minus 2 with the multiplicity of 2. And last but not least, we want to factor each expression completely. Let's factor each expression completely. This first one here, what can we do here? We can factor out a. All right, now can we factor this? Math eyes. Look at this. Can we factor? Well, 25 times 3. I'm going to do it this way. Does 75 have two factors that add up to 20? So go back to those factoring strategies that we learned back in the day, early in the school year. And we have 5 times 15 equals 75. 5 plus 15, I'm pretty sure that equals 20. So we can factor that out, a, and now we have a plus 5, a plus 15, and we need to divide by our leading coefficient of 25. So this gives us a, now a plus 1/5, a plus 3/5. And we need to simplify this. So putting it, and if we remember when we were doing our factoring of our quadratics, when a is greater than 1, the way we write our answer, we just take this denominator and move it over, and it becomes the coefficient. So 5a plus 1. And over here, move that denominator over, 5a, and drop down our numerator, plus 3. Wow. And we box our answers. 18 minus 50y squared. Again, what can we do here? Well, we have two even numbers, so I know we can factor out a 2. And when we factor out 2, that gives us 9 minus 25y squared. 9 and 25 don't have any common factors, so this is prime, and we're done. Psych. We have two perfect squares here. Well, three perfect squares, 9, 25, and y squared. So factoring that difference of two squares, square root of 9, square root of 25, and square root of y squared. And we do it again with the plus sign, square root of 9, square root 25, and square root of y squared. Now we have our answer. All right. Last one over here, we have a z to the 8th and a z to the 5th, so we know we can factor out z to the 5th. Now 24 and 81, again, you can go back to the factoring strategies, but I'm just going to jump right ahead and say that I know that 3 is the GCF of 24 and 81. So 3z to the 5th, and that's going to leave me with 8z cubed plus 27. 8 and 27, no common factors, so this is now we're prime here, so we're nope. We have a sum of 2 perfect cubes, so that's another one you might want to go back and review if you don't remember how to do this. So we have 3z to the 5th. The cube root of 8 is 2, and the cube root of z cubed is z. The cube root of 27 is 3. So remember, when we are factoring our sum of 2 cubes, it's a plus b when we have the sum. So a is 2z plus 3. So the sign in this first part is always the same. Then we have a squared. So what's 2z squared? 4z squared. So a squared. Then it's minus, all right, the second sign, this sign over here is always opposite, whatever this sign is. So this sign is the same as this one. This sign is going to be opposite. So minus a times b. So 2z times 3 is 6z. And then always positive, so plus, and then we got b squared, so plus 9. And that's going to do it for us on this video.